Okay, today we're looking at section 4.3. How do you solve x squared plus bx plus c equals 0 by factoring? Okay, so the first question is, what is factoring? And the easiest answer I've had for that is factoring is changing something from addition and subtraction into multiplication. So that's what we're going to do in this section. We're going to change this, which is addition and subtraction, into a product of binomials. Okay, so little vocabulary here: monomial, binomial, trinomial. You probably have heard that before, but a monomial is one term, okay, like x squared or something like that. A binomial has two terms. Okay, so an example here is x squared. A binomial would be two terms, like x plus 3 would be a binomial, it has two parts to it. A trinomial has three parts. Okay, so this is a trinomial. So in this section, what we're trying to do is take a trinomial and factor it into two binomials, or possibly into a monomial and a binomial. But we want to make it multiplication. Okay, so let's just look at some basics. If I have these two binomials and I want to multiply them together, I'm kind of working backwards right now. So if I FOIL this, multiply it out, x times x is x squared, x times n would be xn, m times x would be mx, and then m times n. Okay, now if I factor the x out of the middle term, this would look like this. Okay. All I did was factor the x out of each term, and I would get that. So if I was to imagine having something like this and working my way backwards, the term at the end is the product of these two, and the coefficient in the middle is the sum of those two. Okay, so when I factor these trinomials, all I need to do is figure out, okay, what multiplies to get this that adds up to this, and that would factor into a binomial. Okay, you may have heard of something called a diamond problem. You may have done it in algebra. You just make a big X here, and on the top is the product, and the bottom is the sum. So you could write the product, which is negative 18 on the top, negative 3 on the bottom, and then right here is where you write the two numbers that multiply to get this that add up to this. Okay, so in this case it would be negative 6 and positive 3. Multiply to get negative 18, add up to negative 3. So then my binomials would be x minus 6, x plus 3. Okay, you could FOIL that out and just make sure it works. X squared minus 6x plus 3x is that, and then negative 6 times 3 is negative 18. Okay, so that's how we factor those. Okay, so let's look at this one. So two numbers that multiply to get negative 63 that add up to positive 2. So that would be 7 and 9. 9 times 7 is 63. If it's a negative product and a positive sum, you know that one number's negative, one's positive. In this case, the bigger number's positive because it adds up to a positive there. Okay, one quick way to check is to multiply your inside terms and your outside terms. Make sure they add up to the middle. So I get a negative 7x, positive 9x equals 2x. Okay, let's try this one. Okay, I'll even do the diamond problem way. Sometimes it's easy to visualize when you do that. So two numbers that multiply to get 20 add up to negative 9. Okay, so in this case, if the product is positive, the sum is negative, you know that both numbers have to be negative because a negative times a negative is positive. So that's going to be negative 4 and a negative 5. So x minus 4, x minus 5. Okay. Move on to this one. Okay, you can do a diamond problem if you want. Two numbers that multiply to get negative 12 that add up to 3. Okay, so you can think for a while. If you're not sure, you can start writing out all the products of negative 12. Okay, 1 and 12. 2 and 6, 3 and 4. Okay, you know one has to be negative because the sum is positive. You know the bigger number has to be positive and the smaller negative. So do any of those numbers, if I add them, add up to 3? And they don't. So in that case, this one's not factorable. Okay, so that's factoring a trinomial into two binomials. A couple special types of products of factoring, difference of squares. Okay, so if I have a squared minus b squared, I can factor it really quickly by knowing this simple little formula. So how do you know you have a difference of squares? If both terms are perfect square numbers and I have subtraction. Subtraction is difference. Okay, so first you need to know what are the perfect square numbers. Well, I've got the start of the list right here. 4 is a perfect square because 2 squared is 4. 9 is a perfect square, and 3 squared is 9, and so on. So those are the perfect squares. So if I look at this, I can factor that by noticing that this is a x squared. What do I square to get x squared? I square x. What do I square to get 9? I square 3. And then one's a plus, one's a minus. Okay, if I multiply that out, you notice the inside terms and the outside terms basically cancel out. So the bx part of it is 0, goes away. Okay, let's look at this one. What do I square to get 36x squared? Well, it'd be 6x. What do I square to get 49? 7. One's a plus, one's a minus. Okay. Factoring a greatest common factor. This is actually the first thing you should always look for when you factor. A greatest common factor is something that's common in both terms that we can just factor out right away. Okay, so what goes into 5 and 40? Well, 5 does. And there's also an x in both terms, so I can factor it like this, kind of like the opposite of the distributive property. So I've put the 5x out here. That's going to leave me with an x minus 8. Because 5 goes into 48 times. So you can distribute to make sure 5x times x is 5x squared. 5x times 8 is 40. Okay, similar here. What goes into both terms? Well, a 3 does and an x does. So 3x comes out of there. You're going to get an x plus 9. This one, only thing that factors out is an x. So you get an x and an x plus 5. Okay, so that's another special form. Perfect square trinomial is the last one. In that case, we have two perfect squares, and then the middle term actually adds up to the perfect square value of this term. So what do we square to get 36? 6. Okay, 6 plus 6 is 12. So if you notice that, it's a perfect square trinomial. Now, this one's not too big of a deal because we can factor this the same way we factored these ones. Basically, look for two numbers that multiply to get 36 that add up to 12. So you could even do a diamond problem on this. So it would be x and an x and a 6 and a 6. Because 6 times 6 is 36 and 6 plus 6 is 12. Now the only difference here is instead of writing x plus 6 times x plus 6, you could write it like this, x plus 6 squared. Okay. How about this one? You notice that 81 is a perfect square and x squared is a perfect square. So this one's going to be, but notice this is a negative, so it's going to be x minus 9 and x minus 9. Okay. Negative 9 times negative 9 is positive 81. Negative 9 plus negative 9 is negative 18. So I can square that as well. Okay, one last one here. So let's do a diamond on that. 64 and 16. 8 times 8 is 64 and it adds up to 16. So it's x plus 8 squared. Okay, let's move on to solving. Actually solving equations by factoring. Okay, so this is the whole point of it. Okay, so the zero product property is what we use to solve quadratic equations. And here it is right here. If I'm multiplying two things together and I get 0 as a product, well, either A has to be 0 or B has to be 0, or they both have to be 0. That makes sense. So when I solve these, if I can factor them and change them to multiplication, I can solve these. Okay, so let's factor this. Two numbers that multiply to get negative 36 that add up to negative 5. So it would be negative 9 and a positive 4. Okay? So now because this is set equal to 0, we're solving an equation. So we're not just factoring. We have to take it one extra step. And we use the zero product property. So if I multiply these two things together and I get 0, the only way I'm going to get 0 is if this is 0 or this is 0. So what would I have to plug in for x to make this 0? Well, it would have to be positive 9, right? Because 9 minus 9 is 0. This would have to be negative 4, because negative 4 plus 4 is 0. So those are the two solutions to the equation. Now if you're not sure, you can always take this product, or this binomial, and set it equal to 0 and solve that simple little equation. Add 9 to both sides, and you get 9. You could do the same thing to this one. Plus 4 equals 0. Subtract 4 on each side, and you get x equals negative 4. So these are the solutions to this original equation. Okay, so we factor, set each binomial equal to 0, and solve. So in this case, x, two numbers that multiply to get 42. So this is negative 42, and this is negative 1 as my sum. So maybe I need a diamond problem. So that would be 6 times 7 is 42, and that's negative, so it's going to have to be negative. Okay, so set the x plus 6 equals 0, subtract 6, add 7, you get 7. Okay, so those are my solutions. Now this one, notice what kind of factoring is this? This is a greatest common factor type. I can pull an x out of each term, and now this has been factored. Now the two factors are x and x minus 3. So how do I make x be 0? Well, x is 0 if x equals 0. And then x could equal 3. So those are my two solutions there. Okay. Similarly, if they ask you to find the zeros, it basically means the same thing as solve the equation. We're just going to substitute 0 in for y and solve it the same way. Okay, so if it says find the zeros, it's just solving the equation. So then, two numbers that multiply to get negative 14 that add up to 5. That would be 7 and 2, or plus 7 and minus 2. Setting each of those equal to 0, you're going to get x equals negative 7, x equals 2. Similarly here, if we substitute 0 in here, I'll save myself a step. Numbers that multiply to get 30 that add up to negative 7. Think about that for a second. Two numbers that multiply to get 30. Well, 15 and 2 wouldn't work. 6 and 5 wouldn't work. How about 10 times 3? Negative 10 and a positive 3. That'll work. So that's my solution there. Now finally this third one. What kind of factoring is this? That's a difference of squares. So that's x plus 4 and an x minus 4. So x would equal negative 4, and x equals positive 4 for that one. Okay, so that's solving equations by factoring. Now I'll do one quick word problem, fairly straightforward one. So you have a rectangular garden that's 10 by 15, and you want to double the area by adding the same amount to each side. How much would you have to add? So let's draw a picture here real quickly. So here's your original rectangle. This is 10 by 15. I want to add a little bit to the length and the width so that I can double the area. So the original area was 150. Feet squared. So the new area has to be, we want to double it, so that would be 300. Okay, so we don't know how much we're adding here, but we want to add the same amount to each side, so we're going to call that x. So we know the area of a rectangle is length times width. So I could say this side, this whole side is x plus 10. This whole side is x plus 15. And the product of the length times the width has to equal the new area, which is 300. Okay? So to solve that equation, we need to multiply this out. So you get a 10x and a 15x is 25x plus 150 equals 300. Now because it's not equal to 0, I got to get this over to the other side. I'm going to run out of time here, so I got to get through this. Factor that out. And two numbers that multiply to get negative 150 that add up to positive 25 would be, tell you what, I'll let you, my time's running out, so I'm going to let you try to solve that and bring it to class.